This is 11-2, multiplying polynomials. I'm going to show you different methods. Whichever method that you can show your work will work for me. So the first ones is 3n squared times 4n to the fourth. This goes back to when you were dealing with exponents earlier in the year. When I do these exponents, when I do problems like this, I take care of sign, number, letter. That's what my brain tells me. Positive plus a positive is a positive. 3 times 4 is 12. There's n's here. There's 4 n's here. And when I count them out, it's n to the sixth. This is very similar of doing 8 times 4. And I'm going to relate the 5th grade multiplication to algebra multiplication a couple of times. Okay, so this is, again, sign. Negative times a positive is a negative. And then I don't have to deal with that sign anymore. 3 times 5 is 15. There's 2 here. There's 1 here. That's a to the third. There's 3 here. There's 4 here. And there's 7. And that's my answer. Here, this is multiplying. It's actually a distributive property, but it's stretching it out. So it's negative times a positive is a negative. 6 times 1 is 6. T and tt is t to the third. Negative 6 times positive 5 is negative 30. T times t is t squared. Negative 6 times negative 9 is positive 54t. Now, this is the same way as going 431 times 2, where you would go 2 times 1 is 2, 2 times 3 is 6, 2 times 4 is 8. And I'm going to do this because I'm going to build on this process. So this is t squared plus 5t minus 9 times negative 6t. There's not anything on there. And so it would be here times here, which is positive 54t. Here times here, which is negative 30t squared. And here times here, which is negative 6t to the third. I end up with the same answer. It's just I'm building off of this algorithm to do that. Okay, because this is the reason I'm building that, is because I know of at least 3 methods to do this, and I'm going to go through 2 of them. Okay, so the first one is FOIL, and it stands for first, outer, inner, last. It's a double distributive, and it is a linear problem. And so you would go 2x times x, which is 2x squared, 2x times 1, which is plus 2x, negative 3x, and negative 3 times that, which is negative 3. Then you would combine like terms, and these are your like terms, and it would be 2x squared minus 3x minus 3. My least preferred method. 2x minus 3 times x plus 1. Just like when you did 41 times 23, and you did 3 times 1 is 3, 3 times 4 is 12, placeholder 0, 2 times 1 is 2, 2 times 4 is 8, add them together, and that's how you do it. I use that algorithm. So I go 1 times negative 3 is negative 3, 1 times 2x is 2x, placeholder 0. I know 0 doesn't have a positive or negative, but in my brain it's positive 0, just so it lines up. X times negative 3 is negative 3x. X times 2x is 2x squared. And by me doing this, my terms are now lined up, where that's negative 3, negative x, and 2x squared. And I end up at the same place. Just to me, because I can multiply like that. I learned it in 5th grade. Why not use it to algebra? Here, the FOIL method, 3x minus 4 times 3x minus 4. First times here times here. 3, oops, not 3. 9x squared. Here times here, minus 12x. Here times here, minus 12x. Here times here. Plus 16. 9x squared minus 24x plus 16. And you do realize that after you learned how to multiply in grade school, you learned how to divide. So be on the lookout for patterns because you're going to have to go from here back to here. And there are some clues of that. Okay, here we go. If I did it, 3x minus 4, 3x minus 4, because this says write it down twice, positive 16, here times here is negative 12x, placeholder 0, negative 12x, 9x squared, 9x squared minus 24x plus 16. I end up at the same place. I just like the second method better. Okay, these are called perfect squares. How do I recognize a perfect square? I have the same first term and the second term of my polynomials when I have them are the same but opposite signs. And you're going to have to start recognizing them because they do peculiar things. So I'm going to pull the x plus 7 right there. And I'm going to do it by my method. So I get here times here is negative 49. Here times here is positive 7x, placeholder 0. Here times here is negative 7x. And here times here is x squared. These go out. You get x squared minus 49. The reason why they're a perfect square is because I'm squaring that with the negative and I have x squared. After a while, you're going to recognize that and go, oh, that's x squared minus 49. They're very common. Okay, if you were to do it by FOIL, here to here, 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 here to here. 3x squared plus 2x minus 5. 2x plus 3. Here times here is negative 15. Here times here is positive 6x. Notice I'm putting my signs and I line them up. Here times here is 9x squared. I'm going to put a plus 0. Here times here is negative 10x. Here times here is 4x squared. Here times here is 6x cubed. Now the reason I like that is because I've learned to pay attention to my terms, and notice I was pausing. I was making sure that when I put them under it, I'm actually combining like terms. Negative 15 minus 4x, and I'm adding here and combining them that way, plus 13x squared. And 6x cubed. Now, make sure you are combining by addition and subtraction through here. You don't want to accidentally do that as negative 60x. And here's a 3 by 3. So I get 2. I'm going to just put the other one directly underneath it. And I'm going to have 5x squared minus 3x plus 2. And remember when you did 121 times 232, that algorithm is the same thing. So I'm going to take the 2. Here times here, plus 10. Here times here, negative 8x. Here times here, 4x squared. Going to the second term, I have a positive 0. Here times here, negative 15x. Here times here, positive 12x squared. Here times here, negative 6x cubed. Remember, if you were multiplying here, you would add 2 zeros. Here times here, plus 25x squared. Here times here, minus 20x cubed. Here times here, 10x to the fourth. Remember that you're adding. You can go either way because they're already lined up. 10x to the fourth minus 26x cubed plus 41x squared minus 23x plus 10. Okay, when we are doing these, they're saying look for a pattern, a negative and a positive, a negative and a negative, a positive and a negative, a positive and a positive. This is trying to prep you for when we factor, because these things. Now I'm going to do these. I'm going to use a space over here. I have x plus 7, x minus 2. Negative 2 times positive 7, negative 14. Negative 2 times x is negative 2x. X times placeholder 0. X times 7, 7x. X times x, x squared. Minus 14, positive 5x, x squared. When you have this, this tells me the signs are different, and the signs are different. This tells me the sign of the bigger, and the sign of the bigger is positive. So that's for when we factor. Next one, x minus 4 times x minus 5, positive 20, negative 5x, plus 0, negative 4x, x squared. 20, negative 9x, x squared. That's a positive. This says the signs are the same. This is the sign of the bigger. Signs are the same. This is, and when I'm talking about bigger, I'm talking about bigger here and bigger here. I know negative 5 is less than negative 4, but I'm looking at this guy right here. Okay, and 5 is bigger than 4. Signs are the same. This is always sign of bigger. Signs are different, sign of bigger. Okay, next one. X plus 6, x minus 8, negative 48, negative 8x, plus 0, plus 6x, and x squared. Negative 48, negative 2x, x squared. Signs are different. Sign of larger. 8 is larger, it had the negative. Because this will change if this was x minus 6 and x plus 8. So I'm sorry. We're learning how to multiply and then see stuff. Okay. X plus 1, x plus 9. Positive 9, 9x. 1x, x squared. 9 plus 10x and x squared. These are, signs are the same. Sign of larger. Now, when they're like this, some people do what's called rainbows. Here and here. Gives you your middle term. So, first times first gets you x squared. You have to do this. 9x and 1x is 10x, and then the numbers go together, which is 9. It's a little harder to do that. Some of you can manipulate it. I prefer you not do it at the very first. Okay, a minus 2